December 30th, 2023, residents of Mukuku village in Kenya were startled by a thunderous crash. A massive, smoldering metal ring, 2.5 meters, 8 feet wide and weighing nearly 500 kilograms, had plummeted from the sky, embedding itself in the ground. Just months earlier, in western Uganda, villagers reported seeing fiery streaks before debris rained down across a 40-kilometer-wide area. These were not natural meteorites. They were remnants of defunct satellites and spent rocket stages, falling uncontrollably back to Earth. This video explores the causes, risks, and potential solutions to the space debris crisis before it leads to catastrophe. This phenomenon is becoming alarmingly common. From Texas to Saudi Arabia, from Cape Town to the Amazon rainforest, space debris is raining down on our planet. While some objects burn up harmlessly in the atmosphere, others, especially those made of titanium and heat-resistant alloys, survive re-entry and crash into populated areas.
5, 3, 2, 1, 0.
With the rapid expansion of commercial spaceflight, thousands of satellites are being launched each year, yet few companies or governments have effective plans to remove them safely. The result? A growing cloud of space junk that threatens people on the ground, airplanes in flight, and even future space missions. Low Earth orbit, LEO, the region between 160 kilometers and 2,000 kilometers above Earth's surface, is the most congested orbital zone. It houses satellites, communications, weather, military and scientific, the International Space Station, ISS, thousands of defunct spacecraft and rocket stages. Since the launch of Sputnik in 1957, humanity has sent over 15,000 satellites into space, but only about 4,000 remain operational today. The rest are either derelict or have broken into smaller fragments. Most satellites are not designed for controlled re-entry. Instead, they are left to decay naturally, meaning no one knows exactly where they will land. In 2022, a 23-ton Chinese Long March 5B rocket stage crashed unpredictably over the Indian Ocean. In 2021, debris from a SpaceX Falcon 9 rocket landed on a farm in Washington state. The World Economic Forum predicts that by 2030, more than 60,000 satellites will be in orbit, most of which will eventually become debris. In 1978, NASA scientist Donald Kessler proposed a terrifying scenario, Kessler syndrome. This occurs when the density of space debris becomes so high that collisions create a self-sustaining cascade of fragments, making entire orbital regions unusable. As of 2024, there are over 36,000 tracked debris objects larger than 10 centimeters. Millions of smaller, untracked fragments, 110 centimeters, pose an even greater risk. A single collision, like the 2009 crash between Iridium-33 and Cosmos 2251, can generate thousands of new debris pieces. If left unchecked, Kessler syndrome could cut off access to space for decades. Risk to people and property. In 1979, NASA's Skylab station broke apart over Western Australia, scattering debris across remote areas. In 1997, a woman in Oklahoma was struck but unharmed by a piece of a Delta II rocket. Threat to aviation. Over 10,000 commercial flights are in the air at any given time. In 2022, U.S. airspace was briefly shut down due to an uncontrolled rocket re-entry. A high-speed debris strike could cause a mid-air disaster, yet no global warning system exists. Risk to active satellites in the ISS. While the odds of being hit might seem low, the risk increases as more debris falls. The ISS has had to perform multiple emergency maneuvers to avoid collisions. In 2021, a Russian anti-satellite test created 1,500 new debris fragments, forcing astronauts to shelter in escape capsules. Lack of regulation. Unlike air traffic, space traffic has no binding international laws. The Outer Space Treaty, 1967, holds nations responsible for their space objects, but enforcement is weak. The rise of mega constellations. Companies like SpaceX, Starlink, Amazon, Project Kuiper, and OneWeb are launching thousands of satellites. Many lack deorbiting plans, increasing future debris risks. Poor satellite design. Many older satellites were not built for controlled disposal. Modern satellites still often lack fail-safe re-entry mechanisms. Active debris removal, ADR, technologies. ESA's Clear Space, One Mission 2026 will test debris capture. Japan's magnetic tether experiments aim to slow down debris. Mandatory deorbiting policies. Experts say the UN should enforce a 25-year rule. Satellites must deorbit within 25 years of mission end. Tax incentives for debris-clearing startups could spur innovation. Better tracking and early warning systems. AI-powered radar networks could improve debris monitoring. Global air traffic alerts for uncontrolled re-entries. Sustainable satellite design. Burn-up-friendly materials that disintegrate completely. Onboard propulsion for controlled re-entry. Space debris is no longer a distant threat. It's a clear and present danger. Without urgent action, we risk a catastrophic ground impact in a populated area, or a mid-air aviation disaster, or our planet might experience the Kessler syndrome, rendering space unusable. Governments, companies, and international bodies must act now, before it's too late. Would you feel safe if a 500 kg metal ring fell near your home? The time to address this crisis is before tragedy strikes.